is.
So information is this, you could say, physical quantity that is, pervasive throughout nature, but it obviously has a use, and its use is realized in some sense through computation. Now, I've heard computation discussed in a number of different places, but I've always been a little bit perplexed as to what it actually is. Like, how does something compute something, and what is the how is it so universal, and just how does it work? It's always been a bit confusing to me, because like these little molecules are engaged in computation. Our cells are engaged in computation. Everything, all of life is a big computation. But I don't really understand what that is.
Well, and I think quite rightly you don't understand it, because I think nobody does. I should say that's a relief. that you're absolutely right. The one way of thinking about the entire universe is it's like a gigantic computer, because at any given moment, the material bodies of the universe, whatever scale you want to put it on, are in a certain state, and later on they're in a different state, and so that's like input output, and you could say, well, the universe is computing its own destiny or something like that. People write eloquently about this, but the big problem, I think, with this word computation is, when is simple information processing, just churning bits around, input output, when is that actually something like a computation? Which the word computation seems to imply some sort of utility that's involved. You compute something, not so in other words, you could take a collection of dice in a box with at rest, with numbers facing up, and you could write down what that is, and you could shake the box, and then you could write down the numbers that you see at the end of that process, and then there's an input and an output. Has it computed anything? Well, no, it's just turned one lot of information into another. But that's quite different if the output of the answer is a search for something. It might be a search algorithm, or we're trying to find an optimal path between two states or something, which is a computation. Now, some people have tried to get to grips with this. So David Wolpert at the Santa Fe Institute for the Study of Complexity has written at least about the thermodynamic cost of computation, as opposed to just general information processing. And so some people are really thinking about these deep issues, but I would say we don't yet have a very clear idea of when mere bit processing amounts to something more specific like a computation.
So there is a distinction between computation and information processing.
I would say there is. I'd say when we're using the word computation, it does imply that there is an additional goal, or the information, that the pathway of information processing is constrained in some way. There's some external factor or criterion or value that we impose to dignify with the term computation. I gave the example, if you want to look for some optimal pathway, if you want to solve, I mean, there's a famous one, of course, the traveling salesman problem. If you've got 10 cities and you want to visit each of them in turn, and you want to minimize the amount of travel between them, how do you work that out? And a conventional computer will do it really by brute force. But however it's done, it's possible a quantum computer might find a shortcut. We don't know that yet. But anyway, you can certainly say, well, here's the answer, here's the output, this is the sequence of cities. And I would call that a computation, because it's not just saying, well, let's just start out with some particular route and then arbitrarily change the routing and then look at where we've got. You're actually trying to achieve something. So I think there has to be something like an end goal or a purpose or a point in the information processing to make it a computation.
Yeah, that makes some sense to me. What I gathered from your book is that a lot of, well, life itself, but a lot of these molecules are kind of, when I say molecules, I mean, these little molecular engines, or these little ratchets, as you call them. They are kind of by design built with the capacity to process information. And while there is like some goal perhaps in that processing, one could imagine many other forms of molecules that do not exist within life, but by virtue of their composition, they end up processing information in some way.
Yes, I think life is a good example. As I said earlier, that if you've got information processing with some sort of goal or global overall value or some criterion, why it's not just arbitrary processing bits. And life would seem to fit that definition. So the computer analogy with life runs very deep, and I think it's very popular. People are familiar with the fact we were just earlier on talking about the genetic code. Life uses coded information, which is transmitted and translated and implemented, and it's a rule book for life, a code book for life. And that means that it's a set of instructions, and instructions have to have a purpose or a function or a meaning. And all of this goes into the normal way we understand life. And what makes that baffling in physics is that we don't see meaning or purpose or anything like that in the laws of physics. We just see molecules interacting and forces and concepts like energy and entropy. These enter into physics, but when we flip to talking about life speak, biology, we very much talk in terms of goals and purposes and signals, and even these days, of course, it's very familiar to talk about gene editing. So we think of genes as really like a text that can be edited now. There's technology available to rewrite the genes. And so genes, life writes genes and it reads out genes, and we can now do this ourselves. And so it's very much the language of information and of some sort of text that is editable.